Okay, today we're going to use the discriminant to find the solutions where they exist, or the real solutions. Can we start? No, just leave it rolling. I'll walk in. We can edit, can't we? Okay. Okay, today we're going to look at the solutions of quadratics using something called the discriminant, which is more of a guide to what type of solutions we're going to get for a quadratic. So here we have three equations, and fairly similar, except really the only difference is this last term, the constant. Now think about when you're graphing a quadratic, there's sort of three possibilities we could have in terms of x-intercepts. All quadratics have to have a y-intercept, they've got to have a turning point, or else they're not really a quadratic, are they? But in terms of the x-intercept, and this is a quick sketch, we could have a couple of options. We could have one where it comes down and it has two x-intercepts. We can have another option where it comes down and just touches. So that means the turning point is also a solution, is on the x-intercept. We could of course have the third option where it comes down and it crosses the y-axis but not the x-axis, so it actually has no roots, or I should be absolutely correct, it has no real solutions. There may still be solutions, but they are not real, so you've got to think of real numbers when you do them. So how do we figure out which equation matches which graph? They all may match one, or they all may be different. You can pretty much guess they're all going to be different. What we do is we use, think of a quadratic equation first in a general form. Ax squared plus bx plus c equals 0. If you're trying to solve a quadratic, it's often nice to get it in this form. And we're going to use something called the discriminant, which looks like this. This is the symbol for the discriminant, which is b squared minus 4ac. Okay? And now, if the discriminant is greater than 0, we have two real solutions. Okay? And that matches, let's use a different colour, that matches this graph. Okay? If we have the discriminant, using symbol delta, equals 0, we have one real solution, which matches when the graph is just touching. Okay, so the turning point is on the x-axis. The final one is when delta, or the discriminant, is less than 0. And this is where we have no real solutions. And that matches the graph where it doesn't cross the x-axis at all, or come in contact with it. So we've got to figure out which ones are these. There are other ways to do it. You could try completing the square, and then for some of these you'll get stuck and not be able to progress. So this is a really quick, surefire way of showing whether you have solutions or not. Okay, so keep that formula up there, and just get rid of the scuff. Okay, so we're going to use this sort of process. So for number 1, okay, let's just think about our values, reading off. Our A is 1, our B is -6, and our C equals 9. So our discriminant is going to be b squared minus 4ac. So I'm going to have, always use brackets once you've got a negative number, just reminds you, b squared minus 4 times 1 times 9. Always put this substitution line in, don't try to do it in your head, because invariably the negatives will get you. So we have 36 minus, hopefully, 36, who would have thought, and we get 0. So that leads us to the situation where this equation has one real solution. So if we graphed y equals that expression, we would get a parabola where it touches, just touches the axis, i.e. the turning point. So it's actually going to work because you've already got the x-coordinate of the turning point. You could get that out of that. Alright, the second one, a equals 1, b equals -6 again, and c equals 16. In this scenario, you're going to get delta equals -6 squared minus 4 times 1 times 16. So you're going to get 36 minus 64, which is going to give you minus 28. Okay? Yes? Okay, I'm getting agreement from the peanut gallery. Okay. And you say, since it is less than 0, the discriminant for this question is less than 0, there are no real solutions. For those of you who are also doing general maths specialists, the important thing to realise is we put this real in there because there could be things called imaginary solutions. And if you want to know more, go to your general maths specialist. The third option, I think we can predict where it's going to go, but let's just verify that it does go there. We have b equals -6 again, and we have c equals 4. Oh, yes. Alright, discriminant is going to be, I know the process can seem a little dull, but stick to it and it'll stick by you. We get 36 minus 16, which is 20, and there we go. We have the discriminant is greater than 0. There are 2 real solutions. Okay? I really do recommend you set it out like this, and the reason is, if you get an A or a C value that is negative, setting it out like this in the brackets is going to save you, because it's going to slow you down and make you realise that you've got a negative and a negative here, which is something really important to watch out. So have a go for yourself.